Okay, hello everyone. I'm Dainius Masiliunas. I'm from Wageningen University and Research, and today my talk is going to be about the implementation of multiple monitors in the Open Earth Monitor project on openEO. So first of all, what is the openEO API to begin with? It is a particular specification which allows users to connect to different backends using one unified language underlying openEO. And that means that we can use it to upscale large Earth observation data processing on European infrastructure. And compared to commercial offerings such as from Google Earth Engine, it allows us to run code that is not necessarily already embedded in the specification. So we have this option to run user-defined functions, which currently are mostly based on Python. But that means that basically any Python code that we want to run is able to run, and therefore we're not limited in what we can actually do with all the data. So on the right, you see that if you have multiple clients, in the past, they used to have to communicate to every backend using the language of each backend. But with openEO, we have basically a translation layer that allows all the clients to use the same tools and the same language to connect to all of the different backends, which makes them a lot more interoperable. And the most well-known backend is the Copernicus Data Space Ecosystem, or CDSE. It's far from the only one, though. And in this project, we also use multiple of them, which I will be talking a bit about later. So as a developer, you write scripts in your preferred language because there's a client in R and Python and also JavaScript. There's a web client as well. And for users, it's nice because all of these algorithms that have already been developed, they can be accessed through a web interface that allows you to just pick an algorithm and run it on your area of interest and your time of interest. And then you just wait for a map to be generated and you can download it directly. So you don't necessarily need to know anything about this complicated work that goes behind the scenes. And that's available through this algorithm plaza. So what do we do with openEO and Open Earth Monitor? So far, we have three use cases, which are implemented in openEO. Some of them are still in progress, and we're also in talks with one more use case to also get it to run on openEO, but we'll see how that works out. So the ones that are already running are the Tropical Deforestation Monitoring and Characterization tool, the EU Snow Monitor, and EU Air Quality Monitor. The first two are running on Copernicus Data Space Ecosystem, and the last one is running on openEO platform. So I will shortly introduce all of these. So the EU Snow Monitor is a use case by EUREC Research, and they are working on monitoring daily high-resolution snow water equivalent in particular mountain regions in the Alps. There's an already developed algorithm to calculate the snow water equivalent, which you can see down here. And the idea is to move this all to openEO so that it can be upscaled easier. The algorithm involves using a support vector machine, which is trained on every scene, and using a lot of covariates that are available on Copernicus Data Space Ecosystem. But I will not spend too much time on this because there will be a hands-on workshop at 13:30 that is organized by EUREC. So please go there if you are interested to know more. I will spend a bit more time talking about the EU air quality monitor because I believe it will not be explicitly introduced in the workshop that we have. So the air quality monitor is another use case that is implemented by the University of Münster. And it is about monitoring the following variables. So nitrogen dioxide, particulate matter 2.5 and 10, and also ozone throughout the entirety of EU. And it is based on data from ground stations. So that's European Environmental Agency ground stations, but also incorporating some citizen science data as well. And the idea is that it is able to do predictions at hourly, daily, monthly, and annual scales. And it is based on interpolating the ground station data, but making use also of European data from the Copernicus services, Copernicus Climate Change Service, Copernicus Atmosphere Monitoring Service, and also Copernicus Land Monitoring Service. It's all based on free and open source software, and it is running both in R locally and also implemented on openEO using UDF in Python. So I'll go a bit more in detail about how it is actually implemented at the moment. So here you can see what we call a process graph, and it details what exactly goes on behind the scenes in openEO. So every of these blocks is a process in openEO, which is basically a function that it performs on the input data and produces an output. So here you can see that we have three types of input. So one input is from the Copernicus Atmosphere Monitoring Service, and these are modeled data. And there's also modeled climate data from the ERA5 dataset, which is a well-known climate dataset. These are all merged together using this merge cubes process. And then also it is combined with ground station point data that I mentioned from the European Environmental Agency and citizen science. And then most importantly, this is all combined together in a user-defined function that is working on spatial interpolation. And this part is actually the biggest part. So it does linear regression on the input data, and then it also applies kriging to do spatial interpolation. And then it produces output given the user-defined input data in terms of what is the temporal extent that the users are interested in. As I mentioned, it can be like monthly, yearly, or daily. And you can try it out yourself as well. So we have two demos that you can check it out. And the main platform that we try to apply this on is openEO platform. We also are trying to get it running on CDSC as well. So then you can choose between two different backends. But openEO platform has a bit more of the data that we need in order to run this use case. With CDSC, it's also possible, but this data then needs to be transferred over to CDSC, and that takes longer than just directly accessing it through openEO platform. So in the first case, you can see how to run it on openEO platform. And also you can check out more details about the algorithm itself, and you can run it on Python or also on R. And here there's a Jupyter notebook that you can take a look at and try it out for yourself. So that was the second use case. The third use case is the monitor of tropical deforestation and its drivers. And this is about monitoring tropical deforestation and what causes this tropical deforestation. This is implemented by Wageningen University, and it is there to support tropical country cases such as mapping commodity crops and also for EUDR compliance in the future. It's making use of Sentinel-1 data and Sentinel-2 data, and also an AI model. So it's based on a convolutional neural network. And it produces a map that maps a very large number of commodities, which you can see over here. And the product itself is completed. So based on this workflow, it is currently ongoing validation, and there's also a paper in preparation. But also you will hear more details about it in the following talk by Robert Masiliunas. Here is just some output that you can see that we have the ability to map some advanced commodity crops. to detect, for example, new oil palm farms that have been established or cocoa plantations. And it's making use of this deep learning model where I will show you a little bit about how that is actually implemented in openEO. And here I also want to mention that, again, you can make use of it also on your own to check out how it works. It is implemented on Copernicus Data Space ecosystem. So if you want to try to run it there, you can go in this link with this QR code. And then if you want to try to run it locally on Jupyter Notebook using this Onyx system to run the CNN there, it's also very easy to do that. There's a Jupyter Notebook that you can try and run it locally on your own computer. So what it does is it first asks you to select your area of interest. So we can select a small area so that it doesn't take too long to run. And then the process graph looks like this. So the whole processing chain starts with taking as an input the Sentinel-1 data and also Sentinel-2 data. And it's also making use of the digital elevation model from Copernicus, so the Copernicus 30 dataset. First, it takes the average over time so that you only get one image over the time span that you specify. Then everything gets resampled to the same resolution. It's making use of Sentinel-2 resolution as the baseline, so everything else gets resampled to that resolution. And then everything gets merged into one intermediary product. And then we also rename the labels so that the bands are properly named so that we know what we're actually using. And then we apply a pre-processing user-defined function, which does things such as normalizing all of the input data so that it's scaled between 0 and 1, and doing other things like cloud masking and so on. And then we also rename the labels to make sure that everything is correctly set up. We get an NDVI input also from our pre-processing, and we also add an additional 2 bands, which are the coordinates, so X and Y, to make sure that the algorithm can optimize for a particular location. And then finally, the main processing is done by this apply neighborhood call, which is also making use of another user-defined function, which actually runs our deep learning convolutional neural network model over a given subset of the area, and it is run using a moving window. There's an overlap, and then this overlap allows us to do multiple predictions and then take an average of them so that we get the best prediction out of multiple runs. And then we get the result. So in practice, the result looks like this. Here's one example area where we can see a bit of an urban area to the top right, which is predicted here as built up. And then we also have different fields, and each field is identified with the crop that is there. It's mostly cocoa plantations here, but you can also clearly see the roads that are there to do the management for these crops. And you can also see patches of different types of crops in this whole area. And you can get this through openEO, and also you can run it on your own computer, and then you can also see what are the differences and so on. But again, you will get more information about that in the following talk. So I will conclude this, that openEO allows us to upscale this kind of complex processing chains by running them on European cloud infrastructure. We can port existing chains that allow us to implement rather complicated models and do this kind of prediction on a more global scale, making use of the products that are already provided by the backend providers such as CDSC and openEO platform. And both of these platforms provide similar but complementary data sets. So which one to use depends a lot on the use case, which data it requires to run well. And by making use of these user-defined functions, we can run arbitrary code, which allows us to implement such functionality that is not already existing in built-in openEO functionality, which allows us to extend a lot what we can actually do with openEO at the moment. And a big use case is machine learning. We are currently also working on extensions to openEO that makes it much easier to train and also predict using these trained models on openEO directly. And in the meanwhile, making use of user-defined functions works well. And in the end, when these processing chains are already developed, we can deploy them on these algorithm plazas that are available on CDSC and also on this European Space Agency Apex platform in order to allow users to run it on their own in an easy fashion by just selecting an area and time of interest, and then directly get a snow cover or air quality or land use map based on all these workflows that I was just mentioning. Or if they want to use it for their own development, make use of these processing chains as like its own small process, which that can be combined with any other data that is available on these platforms to further do processing for their own products in the end. And it's all open source software, so it will be available after the end of the OMC project as well. And since it's integrated into these large openEO processing platforms, it allows interoperability also with outputs from other projects or other outputs that the users are working on in these platforms. So that concludes my talk, and I will give some time for questions.
Questions, thank you, Dainius. So you can see me, I think, but there's a whole audience also here waiting to ask or comment on. No, maybe then I start. This model builder, the visual model builder, it reminds me my son is now into Scratch, Scratch 3. So it reminds me of this visual programming, but is that the idea to make it easier for so to people that are not high level coders? Is that the idea, or is just to visualize what you made in code?
Well, it's both. So you can make use of this editor on the web in order to create your own functionalities and your workflows. But you can also make use of R and Python, which will build these kinds of chains for you. And these are all interoperable. So if you have a processing chain that you created with Python or R, you can export this processing chain to the web editor, and then you can visualize it there. So there's no real limitation. So you can choose which one you're the most comfortable with and then develop it there. So I would say the web editor is a little bit more useful when you're exploring how to create these processing chains, because there you can see quite easily all of the input data that is available on the backend. But then if you want to combine it with local data, then it makes more sense to use a local client like an R and Python, so that you can also see how you can combine these data sets together. But there's no real limitation. So you can choose really what you
And
like.
just one more thing, if you can clarify the difference between openEO platform and CDSC. Obviously, CDSC is a much larger infrastructure. It's more generic. So do you see these things, two systems, are they really something you consider that for broader use for like new researchers? Do you think that both systems are interesting, or you just use this openEO platform just for comparison, but we really have to focus on CDSC? Maybe you should comment on that, please.
Yes, so openEO platform is actually the earlier infrastructure. It is mostly based on infrastructure made by Vito in Belgium. And it is basically a European Space Agency project. It has been running for a while and it has concluded, but it has also been extended so that it can be still used by the broader audience. And I think it really will depend a lot on what the European Space Agency is going to decide to do next for it. It could decide to keep it running for the future, or maybe not. So there's a little bit more of an uncertainty there. For CDSC, it's more clear that they see it as the future infrastructure, and there's a lot of buy-in there. But it's also something to keep an eye on. The thing is that all of these backends are all open source, so actually it doesn't necessarily matter which one you interface with, because all of the code that makes the backend run can be deployed on other infrastructures as well. So if you develop a workflow on one, you can port it to another one without any issues. The only real difference is the input data sets. And that's, I think, the key distinguishing factor.
Okay, we have one more question for you, Dainius, from Yufeng.
Yep. Dainius, thanks for your talk. I have a question just to how can we contribute to openEO, because I think it's a really cool backend open source software. For example, I have ideas to actually optimize, for example, cloud native factor format processing. And in this case, or also different function, how can I contribute to openEO, and how can you ingest into the backend, or will we just derive some side project and do it by my own? So how does it work?
Yeah, of course, it depends on the details of what you would like to contribute, because there are two different levels. So you have openEO API, which is the language that is used to communicate between the client and the server. And then there's also these individual implementations like CDSC, like openEO platform. So depending on which level you're interacting with, you need to contact different working groups. So for the openEO API, if you want to have changes in how the clients and the backends communicate, then it's based on an open process by the openEO consortium. It's on GitHub. You can suggest changes as a proposal. You can put a pull request or you can make an issue. It will be discussed in the steering committee, and then they will approve it or not. And if you want to have it implemented specifically for one of the backends, then you need to talk with the developers from the backend. So the CDSC implementation or the openEO platform, so that is headed by Vito. So you need to talk with one of them.
Okay, we stop here. We have to move on with thank you, Dainius. Thank you for investing your time for this. Much appreciated. Please stay with us.